Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development. Paradigms are ways of looking at the world around us. Programming paradigms are ways in which we look at programming styles, languages, and frameworks to classify and understand the world in which we code. In this episode, we dive headfirst into the Wikipedia rabbit trail that is programming paradigms. We'll start off talking about paradigms in general and what defines a programming language, then dive into a few dichotomies in programming paradigms, discussing several specific examples of popular paradigms along the way. But before we get started, Will, what have you been fighting this week?
GoDaddy. This is 2 months in a row that I have gotten a bill more than $120 where they have changed settings in there and said, oh, you're renewing a domain that you've always renewed yearly. Let's renew it for $5. And let's hit you with your in the cash flow right before Christmas. So I got a Namecheap account just before we got on to record, and I am moving everything tomorrow. They're fired.
I use 1-in-1 and have not had any problems with them.
I could do that too. I mean,
it's a European country. I think they got bought out by Ionos. But even after that, I barely noticed any change. They don't mess with my stuff. It's really well maintained. I'm very impressed with them. I have been before I even got into programming. Like the websites I owned when I was back in before med school was through 1-in-1, and I've been with them the whole time because I just think they're great.
I mean, I'll look at those two and compare, but yeah, I just can't have that kind of stuff happening, where somebody just up and decides to essentially steal $100 out of my wallet right before Christmas.
Yeah, that's very frustrating.
Yeah. And they call once a quarter too. So I've had to block their number on my phone because they always called when I was going down the road listening to music. And in Tennessee, you're not supposed to mess with your phone while you're driving. And I have to pick it up and cancel the call so I can listen to whatever I was listening to. And it's obnoxious. I don't want a phone call from any internet company ever. That's what email is for. Email has been there a long time. It works.
Yeah, it's not phone calls are for I need to talk to you now.
Yeah. Send me a telegram. I mean, you're going to use old technology.
As I say, they're for if you need to talk to me now, or if your girlfriend is driving home from work and just wants to chat. Well, you don't have that problem. You're married, so
right.
But no, it's not a problem. I actually really enjoy it when she calls and talks to me. So before we got on, we're actually it's a Thursday. We're recording an extra episode this week because missing last week. But before we got on tonight, I went to the Nashville Tech Council holiday party. I didn't actually go anywhere. It was online because, everything's online these days. And which is, by the way, Will, why I'm wearing the Santa hat.
I was wondering.
Yeah. So they had it was kind of neat. They did a networking, speed networking, where they put up to 4 people in a breakout session chat in Zoom for 8 minutes. And you just basically introduced yourself, and in every single one of them, big surprise, I got to talking. Of course, I wasn't even the only talkative person in them. Almost all of them, I had at least one person who was in sales.
Did they think you were in sales?
No, because I literally introduced myself as a software developer. I don't look like I'm in sales with the long hair and everything. So
you never know. I mean, duck call companies and motorcycle companies have to sell stuff too.
Fair enough. I look more like a musician though, because I'm wearing my Nirvana t-shirt and I've got the guitars in the background. So they all thought I was a musician, and I'm like, yeah, I was a coder before I was a musician. So but yeah, that was kind of cool. I was nominated for the Software Engineer of the Year award, and so the big thing about the holiday party is that's where they announce the finalists. And guess what, guys? I am one of 3 finalists for
Nice.
the Nashville Tech Council Software Engineer of the Year. That's really cool. The award ceremony was originally scheduled for January, but they actually want to bring all of the finalists in person, so they've pushed it back to April. So it's going to be on April 15th, an infamous day over here because that's tax day.
For real.
But yeah, so the ceremony is going to be online, but the finalists will be there in person. So that's kind of cool. I'm looking forward to it. It is a Thursday, so we will not be recording that day, and so that'll be cool. So I can go to it. I'm kind of excited about it. That's been the big thing. I told you guys last week, which for Will and I was 2 days ago, for the recording of it, that I won the individual excellence award at work. So I don't know. My boss, he nominated me for these awards, and I'm really appreciative of it. But he understands me because that's a way to motivate me to work harder.
Yeah.
I'm like, oh, I got an award. I need to be worthy of this award, so I'm going to work that much harder. Speaking of working harder, guys, I've started on this project and I hit my first oh my goodness, it's not just working right off the bat on it. And it's been a while because most of the stuff I've been doing lately has been either kind of bug fixes or building sort of simple things. So building something complicated, I got excited today when I'm like, I have no idea why this isn't working. I get to solve a problem. So
Nice.
that was pretty cool. That really was. Speaking of solving problems, guys, you can take your financial confidence to the next level. Our friend Lucas is a fee-only certified financial planner and financial coach. He owns and runs Level Up Financial Planning, which is this really awesome company. I've had the opportunity to go through their website and look at their pricing model. It's really neat. Will and I both have interacted with Lucas a lot as he's been sponsoring us for several months now.
Yeah, Level Up Financial Planning is a lot like the Complete Developer podcast in that they believe in the importance of having a real plan and taking action so that you can live your best life. It's very congruent with our philosophy here.
Financial planning is expensive, and I've gone on and looked at some of the prices for what Lucas offers, and yeah, it's something that it's not an easy decision to make. It's not something that you just go, oh, hey, I think I'm going to do this. It's a serious decision. It's one that, if you're married or in a serious relationship, you need to get your significant other involved in, because it does cost some money, but it's one of those things that, yeah, it takes money to make money. You go in and you go, hey, I'm going to pay this much money, but I'm going to get like 2, 4, 10 times that back in value, and in not only in what I earn from it, but in the savings and things that I do by following his advice. And he has different tiered models. It's not just for people who are advanced in their careers, but developers starting out with that first time newbie job, you know, do the smart thing, the thing that I should have done but didn't, and start planning for your future now.
Yeah, I think it's really important to understand, what Lucas is offering here. It's you get a seasoned financial planner to actually help you with this stuff. If you've ever gone into a code base that has been written for like a professional application that was written by somebody who learned as they went, you know what kind of mess that makes. And you don't
I've
want,
written those.
yeah, and you don't want that in your finances. So you get a professional to do this. Level Up
Yeah.
Financial Planning is a fiduciary for their clients, which also means that they're required to act in the client's best interest. So Lucas is not a salesman, and you pay as long as you're getting value, and you stop paying when you're not getting value.
Yeah. And guys, you can find some fun free resources and just learn a lot more at levelupfinancialplanning.com.
According to the dictionary, a paradigm is a typical example or pattern of something. In other words, a model. In reference to language, it is a set of linguistic items that form mutually exclusive choices in particular syntactic roles. Programming paradigms classify programming languages based on the features of the language or the rules around how code is written in that language.
Languages can be classified into multiple paradigms. And some languages are specifically designed to be multi paradigm. This allows the programmer, you, the coder, to choose how to best implement the language or framework around that language to meet the needs of the program or app that you're writing. A lot of these languages have a primary paradigm, such as C sharp is primarily object oriented, but you can write functional in C sharp, and it's like the the further along it's gone, the more functional capabilities are in there. Um, and it's really cool because you're able to take these, especially these modern languages that are multi-paradigm, and write write to a specific paradigm in them.
To understand how languages work, we'll start with looking at the Turing machine designed by Alan Turing in 1936. This is a mathematical model of computation defining a machine that manipulates symbols on a strip of tape based on a table of rules. Within this construct, any computer algorithm can be simulated with a Turing machine. Along the same lines, a programming language is said to be Turing complete if it can be used to simulate any Turing machine. What that basically boils down to is that a language is Turing complete if it can simulate or create any given computer algorithm.
Yeah, and that's going to come up several times throughout this episode when we talk about languages being, within a paradigm being Turing complete. So we wanted to establish that from the beginning. It's like, what does it mean when we say it's Turing complete? Programming paradigms are ways of thinking about programming languages or sets of languages. There are a lot of paradigms out there, and they're not mutually exclusive. However, there are a few exclusive dichotomies which languages tend to fall into. Sometimes languages are designed to fit into a paradigm, whereas other times they're built for a purpose and then placed into that paradigm.
In this episode, we're going to look at 3 dichotomies of programming paradigms. First, we'll look at structured versus non-structured languages. Then we'll discuss imperative versus declarative. Finally, we'll look at function level versus value level programming.
So, to start us off, we're going to look at structured versus non-structured. The earliest Turing complete programming paradigm was non-structured.
The non-structured paradigm can be found in both high-level and low-level languages. The flow of programs in non-structured languages uses jumps to labels or addresses.
Yeah, in a lot of these languages, line numbering is very important, and you have go-to statements being the way that those jumps are initiated. And I'm reminded of when I was in high school and we did Q basic.
Yep. I remember that.
And, it was like go to. And it's just like all over the place, especially when you start getting into some more of the complex.
Yeah, but you could do so much with that. I mean, it
Oh
was
yeah.
phenomenal to us, at least, when we started out. Just the fact that I can make a machine do something for me.
Hmm. A certain way of thinking that isn't like, I see it in older developers, like they still have it because they spent so much time in that mode.
Yeah.
But you talk to, people like me. I mean, I'm a weird case because I've got the time I spent in development and then I left and came back. But the people who started around the time I did, or even before that, who never had to deal with non-structured languages, who didn't have to deal with go-to statements and didn't have to think in that mindset about, all right, how do I control the flow of this? How do I, if I go to this line, how do I get back to the control?
Or how do I structure my line numbering in such a way that my program can still be changed? Because that was always
Oh
fun
yeah.
too. It was, renumbering stuff to cram something in there. Oh,
Yep.
yeah. And you can tell I'm one of the older set of developers. Now, I will say, um, you'll also see a slightly less old set of developers who can't get past some of the newer paradigms, like OOP with inheritance, or
Yeah.
three-tiered hierarchies, or those kind of things. They just can't get around that.
Oh
So
yeah.
yeah, it's not a
Absolutely.
shot at older developers at all. It's you get a way of thinking that works with these paradigms, and it works for you, and so you stick with it.
Mhm. Yeah. I mean, it's funny because I've read some articles about uh the old 8-bit Nintendo games and how they would like how they would cram so much into those 8 bits that they had to work with.
Yeah,
And it was a whole different way of thinking back then. And it's kind of a fun way of thinking, if like for me, because I like puzzles and I like to solve things, but it's sort of fun. The thing about it is non-structured programming is really hard to read a lot of times, and can kind of produce some spaghetti
it's
code.
never not hard to read. If it's
Yeah,
anything
that's true.
bigger than Hello World, you're in there for a while.
Though its proponents, one who I read about was Donald Knuth, argue that structured programming can be just as hard to understand.
Oh yeah,
And like I've looked at some stuff, and like some of the arguments he made were, all right, here's a structured program that is basically just is writing unstructured code in a structured language.
yeah. Structured programming was designed to improve the flow and readability of programs. It became popular after a letter by Edgar Dijkstra was this letter was published, and it was entitled "Go-To Statements Considered Harmful." And we'll have a link to that one in the show notes. That's a classic.
Yeah. I read through that in preparing for this. Well, I say I read through it. I didn't have a whole lot of time
We
because we had to
we had
change
an
some stuff
unstructured
around.
schedule with go-tos in it
Yeah, that I
the
mean
last 2 weeks.
it yeah, it's been like, we thought we were going to do one episode tonight, and that didn't happen, so we changed up, and I wrote this last night. So I glanced at it, I skimmed it. I'm going to go back and read it. But structured programming theorem states that a group of flowcharts, or more generically, control flow graphs, can compute any computable function by combining subprograms in one of three ways, either via sequence, selection, or iteration.
So a sequence combines subprograms in a linear fashion with one thing performed after the other. Selection uses a Boolean expression to decide which subprogram to perform, and iteration repeatedly runs a subprogram as long as a Boolean expression is true.
Yeah, so sequence is uh, do this, then this, then this. And it's just like following like a flow. Selection is sort of your if else, if then else statements. Like if this expression is true, then do this, else do that. Um, and then iteration is your loops, your while loops, your for loops, that kind of thing.
Structured programming uses control flow constructs like if else, loops, blocks, and subroutines to guide the flow of a program rather than unstructured jumps to different areas of code. I will point out here, a lot of times when you have the unstructured things, there's comments in there that say what this section does.
Mm-hmm.
And people are trying to get that kind of structure. They just didn't have a paradigm that let them really do it.
Oh yeah, yeah. I remember going through the big program we had with QBasic was that snake game Nibbles.
Yep.
And like QBasic is just my unstructured example because that's the one I'm most familiar with. And we would go through that code just looking to understand. Like there's about 3 of us who were the real nerds of the programming classes in high school. like there's probably about 5 to 10 people in the class, and then there's the 3 of us who were just like really into it, and we would do that. So guys, subroutines are a callable unit of code such as a function or a method that allows a sequence of instructions to be referenced by a single statement. And then a block structured languages have syntax for formally enclosing sets of instructions into blocks of code, kind of like what Will was talking about with the non-structured, where they would use comments to say, hey, this section does this. Well, this formalizes it. For example, in C-based languages, you use the curly brackets, or in, for example, Pascal or Delphi, you would use like a begin end.
While you won't see go-to statements in modern languages in production, you'll be hard-pressed to find fully structured languages too. I say that because there are go-tos in surprising places.
Oh, yeah. Yeah, I know. There are several deviations from structured programming that modern languages use to be more efficient. The most often used deviation is the return statement or an early exit from a loop or function. In a lot of cases, multiple exits from a function are desirable. Even Kent Beck and Martin Fowler suggested having multiple exits in their book on refactoring. The biggest concern is memory leakage because of the lack of cleanup from leaving too early. But this is handled in most modern managed languages.
Well, and there's usually some kind of structure as well for even for unmanaged. People have habits for getting rid of stuff, so usually you can get around it. A specific type of early exit that violates the single exit principle of structured programming is exception handling. Proponents of error handling in structured programming state that at the time Dijkstra wrote the rules of structured programs, that error handling was not in place. So, like back in the day, you might call a function and it errors and it returns you a numeric code for the error, or it might return you a pointer.
Yeah, rather than like throwing an error or going through some type of error management system separate from the actual function.
Yeah, and if you look under the hood with what happens when exceptions are thrown, there's some weird stuff a lot of times.
A less common deviation is the state machine, which will have several states that are not easily converted into structures. State changes tend to be implemented with a jump to the new state. This can be seen in parsers, communication protocols, and even in the Linux kernel.
Yeah, there's a lot of things where speed is really important, and where the state transition is a bigger part of the action than it is in most programs, and so they tend to use that in those contexts. Although you will occasionally see state machines pop up in other stuff too.
Yeah. So the next section that we're going to talk about is imperative versus declarative. And this was basically the idea for this episode. When I put it into our backlog, I was looking at imperative versus declarative languages in one of my classes. And I was like, hey, wouldn't it be cool to do an episode on programming paradigms? And that expanded into the episode that you guys have right now. So in this, we're going to describe first imperative, then declarative. And for each one, we're going to talk about a couple of language paradigms within each one because they're kind of like imperative and declarative are sort of overarching paradigms. Imperative programming changes the state of the program or machine through the code written by the programmer.
So, imperative programming will focus on how a computer will perform an operation by expressing commands for the computer to perform. Recipes are a really good example of a real world imperative design. Each step in the recipe is an instruction, and the real world holds the state.
Yeah. So I think of the recipe for pumpkin pie, which my mom taught me recently. Like, you start off with an empty bowl, and then you put your pumpkin in, and then you have a little subroutine over here to make the spices in a separate small bowl. You put all the spices in there, you mix them up, and then you take that and apply it to the pumpkin in the main bowl. And then you add the other stuff, like, you add your eggs, but you put them, you don't break them and throw them in there. You break them and put them into another bowl, mix them up, and then pour them in there. Like, it's a whole process here, but it's, do this and then come back and bring it in here. In low level imperative languages, statements are instructions that can be translated down to the native machine language. State is then defined by what is specifically held in memory.
At the lowest level, hardware implementations are all imperative because the hardware is designed to execute imperative machine code to change the state of the machine.
Mm-hmm.
Higher level languages use assignment statements to assign values in memory for later use, allowing the program to evaluate complex expressions. They also apply the aspects of combining subprograms, blocks, and subroutines of structured programming with selection, iteration, and sequence.
So, within the imperative programming paradigm, try saying that 5 times fast. That. Yeah, I did. I went there. Anyway,
that was iteration. So,
Yeah. Thank you. Or sequence. I said them in sequence. But I did the same thing. So, yeah, it would be iteration. Procedural languages are a set of programming languages within the imperative paradigm. And they apply this imperative paradigm by grouping sets of instructions into procedures.
So in procedural programming, you essentially, it's structured programming where the state changes are localized to explicit arguments or procedures. So procedures, sets of instructions, in other words, are a series of steps for a computer to follow when executing a program. They may be called at any point in a program, even from other procedures or recursively. So they may call themselves.
Yeah. So within this modularity, and this is important in procedural programming because it limits the interactions the procedure has with the executing environment by specifying input arguments and return values. So it basically makes the procedures modular.
Right. And this is where you get the concept of scope. Scoping in languages is a way to keep procedures from accessing variables of other procedures.
So another imperative set of languages are the object-oriented languages. And object-oriented languages group sets of instructions based on the parts of the state on which they operate.
Objects in object-oriented programming contain both data and the code that acts upon that data. So data is stored as fields, properties, attributes, etc., and code is in the form of methods and procedures that act upon that data.
Yeah. Object-oriented programming, or OOP, it's something we've talked about quite a bit on the show here. both Will and I learned object-oriented programming as probably a primary paradigm, and did it a lot early
Not
on.
both of us. I started a bit before that.
Yeah, you started with I started with procedural too, but the majority of what I learned was object-oriented.
Yeah, it was 2 or 3 years in before I got to OOP.
Okay.
Yeah.
Wow, you really are old, man.
Yeah.
You're only what, a year and a half older than me.
Yeah, but it's not the years, it's the mileage.
That's true. Anyway, object-oriented programming creates objects that interact with one another using side effects to perform the necessary tasks of a program. And what that does is side effects alter the state of variables outside of the local method or object.
In more class-based languages, every object is an instance of a class, with the classes containing the definition for the data types and any methods that work on that object's data. The objects are then specific instances of those classes. So basically the class has the scope for the variables that are within it. So you can make copies and they don't mess with each other if they're instance methods.
Yeah, C# is a class-based language. I'm pretty sure Java is as well.
JavaScript, however, JavaScript is the weird kid. You don't really have classes in prototype-based languages, although they're kind of shoehorning that in to JavaScript. Objects are the main entity. Each object has a prototype, in other words, just one, which itself is an object. The data attributes and methods of a prototype are applied to all objects inheriting from that prototype. Now, this typically also can mean that you can kind of do some funky things to the prototype and make those things show up in the objects that use that prototype. You can approach the way you change code differently, I guess.
Yeah, it also restricts you to single inheritance.
Right. Is not a problem in JavaScript because you can just slap a function anywhere. But
yeah. Yeah, and in some I've seen in some class-based languages where you have single inheritance, where it sort of tries to implement it's funny how we talked earlier in the episode about how languages are cross paradigm, but it goes all the way down to where it's all right, we're not even talking paradigms, we're within a paradigm, the specifics within that. There are languages that are hey, a big surprise at C#. Hey, I like what you're doing over there. I'm just going to take it and apply it to myself.
Yeah. C# is basically the English language of programming languages. Just steal from everybody around you.
I was going to say it's from Microsoft. So
yeah.
It's basically the Borg. It's oh, hey, you have something useful. I'm going to take that and incorporate it into me. Resistance is futile.
So declarative programming is a way of designing and building programs that declare the desired results without describing the control flow or how the program gets that result. One of the main aims with declarative programming is to reduce or even completely remove side effects. This is accomplished by explicitly defining what a program must do in terms of a problem domain instead of defining how the program must do it.
Yeah, declarative languages have explicit content.
Warning parents. Yeah, so a good way to think about this is using your example of the pumpkin pie, right? If you're making the pumpkin pie yourself, you're doing it imperatively. If you ask your mother for a pumpkin pie and she actually makes it for you, that's declarative.
Yeah, because you don't care how it gets made so long as it gets made.
Right.
Yeah. No, that's a really good example. I like that. Declarative programming has a strong resemblance to mathematical and formal logic. In it, programs are viewed as theories of formal logic, with the variables and some procedures as premises, and the computations performed as the deductions from those premises.
Constraint programming involves declaring a set of constraints on a variable or a group of variables. Constraints are not steps in a recipe to get to a solution, but properties of the solution to be found. Algorithms are not so much run as computations are solved by applying values to the variable to meet the constraints of the program. So it's kind of like puzzle solving, as probably the best way to think about that.
So this reminded me of this one game I have on my phone where it's like you have a grid. The big one is the 15 by 15 grid. All right. And for each row and column, it says like how many blocks within that to highlight. So it might be like 10 or 10, 1. So there's like, you have 10 and a 1 within that 15, block row. And so a lot, like the strategy for these puzzles is the first thing you do is you go in and you like, all right, well, if it's 10, the center 5 are going to be there all the time because you got like 5 on one side, 5 on the other. The center 5 of those 15 is always going to be there. So you go and you do all of those that are absolutely there. And then you go in and you go, all right, what constraints can I put on this? So I might have done like a column of 10, but the row is there's only a 5 there. So I know I've got one dot right in the middle. Well, I know there's going to be 4 potential on either side. And after that, it can't be. So that's a constraint. There cannot be anything there. And so I go in, I put in all my constraints, and from the constraints, I can then solve the puzzle. And so that's why I said like it's like puzzle solving here, because it's like that is exactly what I thought of when I thought of constraint programming.
Well, it's kind of like flipping it around, right? Like it's like you're the computer and the Minesweeper game is the program.
Yeah.
Right. So you're getting a set of rules, and you can understand where you are on the grid and you work it out. Now, these are more complicated than just grid based, spatial things.
Mm-hmm.
But that kind of holds that way.
So domain specific languages within declarative programming are languages that are specialized to a specific domain, such as markup languages and regular expressions. HTML only describes what should be on a web page, not how that is rendered in the browser.
Even though people get that wrong more than we would like.
Yeah, well.
Including people on this call right now. On occasion, I cleaned up one this morning. Sorry. The advantage of domain specificity is that the language does not have to be Turing complete, meaning that it's easier for it to be completely declarative.
Yeah. Like HTML. That's just a great example there that almost everyone understands these days, because most things are web-based. And even if you're not a front-end developer, you know some basics of it. Though, I mean, we might have some people who don't know HTML. Guys, if your job, like, it's not just a job that doesn't use it, but if your job involves you not ever having to have known HTML, reach out to us. Yeah. I want to know what you do.
Kind of, especially if you're actually coding and not having to deal with style sheets and all that fun.
Yeah. So, the groups of languages under declarative programming, functional languages. We've had episodes on functional programming. These use expression trees to declare values as a series of function applications.
And an expression tree is an abstract data type where a binary tree structure is used to define an expression. Each node will either be terminal or it will have up to 2 children.
So if you're not familiar with expression trees, look it up. It's definitely something like, I remember when I first started working with Will, he would mention, this creates an expression tree. And I'm like, what are you talking about? And I looked it up and I learned some, and then I started taking courses on it, or not on expression trees, but I started taking graduate courses and really started to understand. And it really changes the way you think about programming when you start understanding the expression trees that are created. Like, what is the machine doing behind your code? What's it doing to your code after you write it to make it work? It like look into this, guys, because it really changed the way I thought about things, and it really pushed me more towards a functional mentality.
Yeah, I think the other thing that it does for you is it sort of it makes you think about how you could mutate your code as you go along, and how you could potentially trim off a lot of excess code or speed things up because you're thinking about the tree that's being generated behind the scenes.
Yeah.
In functional languages, functions are treated as first-class citizens in that they can be passed around as arguments, returned from other functions, and bound by name. Smaller functions are combined modularly to create a composite program of multiple functions. You made me read that because of trying to pronounce modularly, didn't you? Yeah, it's like
yes,
brewery. It's one of those words I just can't say without really focusing on
it. So we just talked about the object-oriented example of imperative programming, in which objects are your first-class citizens. Here, in the functional languages of declarative programming, functions are the first-class citizens. They're what gets passed around. They are like the primary thing that you talk about. Functional programming comes from the use of lambda calculus, which is a system of mathematical logic that uses functions to express computations. And what's really cool is I found this out, like, I didn't get this when I did the episode on functional programming, but lambda
Oh, okay.
Well, no, I didn't find it in the research. Lambda calculus was proven to be equivalent to Turing machines by Alan Turing himself.
Nice.
Like, he mathematically proved them to be equivalent.
Purely functional programming treats functions as mathematical in that they cannot be affected by mutable state or side effects from other functions. So this is like a function in algebra. This means that when an argument is passed into the function, it will always return the same result for the same set of arguments. For example, the function f of x equals x squared always returns 4 when x equals 2.
Yeah. No matter what's going on in the machine, what's going on in the program,
who your accountant is.
Yeah. If you pass in 2 to x squared, it's going to always return 4. That's what purely functional programming does. It always returns the same thing based on what's passed in, not based on the state the machine is in or what happened in another function or some other user input. What gets passed in always returns the same thing.
Yeah. And this is really helpful, by the way, when you need to optimize something, because you can memoize the result that comes out. So you can say, okay, I have this result of calling this function with these parameters. I can just store that result. Anytime I call with those same parameters, I have the guarantee that it's the same.
Yeah, you can. It's basically, I mean, we could get into caching, but we don't. Like, that's a whole another episode. So the other declarative set of languages we're going to talk about, and there's more than these two, but these are the two that are the most well known, is logic. Logical languages are based on formal logic. There's a reason we had that series of episodes on formal logic. It's because it applies to programming, guys. These use a system of facts and rules to declare an answer to a question.
Programs in logical languages are sets of sentences that describe rules or facts about a problem. The rules are written as clauses for formal argument and read declaratively. Facts are rules without a body.
Basically, you set up this set of, if this happens, or if this set of things is the case, then this. If this set of things is the case, then this, going down. And then a fact is basically a declaration like this equals that. Programming in logical languages is basically controlled deductions. Programs are separated into control components and logic components, where the logic component determines the output of the program.
Stricter logical languages like Datalog are only declarative with their execution completed by a proof procedure not controlled by the programmer, whereas less strict languages like Prolog have a procedural interpretation that can be manipulated by the programmer.
Another language is ASP, but not the ASP you're thinking about. There's a few that are stricter, and it's fun because and I'm about to show Will the book. In the book that I used for my class this past semester, we actually learned some Prolog.
Yeah, I had to do that in school too.
As a philosophy minor who really excelled in logic, that was fun. I mean, if I could find a job as a Prolog developer, I mean, I wouldn't leave my current job because I absolutely love it. But, if I could find a way to use it in my current job, I totally would.
Well, I mean, there's something really compelling, right, about being able to set those invariants in English.
Yeah.
And have the program actually follow them versus you have to enforce that constraint.
Yeah. It's kind of cool. So, within this whole paradigm, a horn clause, HORN, is a clause with only atomic formulae or literals. What that means is that the rules and facts that we discussed earlier are all strictly self-contained. So they don't have any subclauses within them. Like, they don't call other logical processes. It's just very simple. This is the simplest, most basic form of a logic program. It's the hello world of logic program.
Or it's the terminal node on an expression tree equivalent. It's kind of what it...
Yeah, that's another way of thinking.
Yeah.
Of it. Yeah.
Because I start to think, you can't do much with it, but if it's at the end and something else uses it, then great.
Now for like I said, that was the imperative versus declarative was the big chunk. That's what spurred this episode and got the whole idea going. Now for something a little bit more fun. We're going to talk about function level versus value level paradigms. And these came about through a man named John Backus.
Programming languages appear to be in trouble. Each successive language incorporates, with a little cleaning up, all the features of its predecessors, plus a few more. Each new language claims new and fashionable features, but the plain fact is that few languages make programming sufficiently cheaper or more reliable to justify the cost of producing and learning to use them.
And so that is a quote from John Backus in his Turing Award lecture. In it, he described a new philosophy in programming design.
Backus was a computer scientist who invented the first high-level programming language, speed code, and led the team that developed Fortran. He also invented BNF, or Backus-Naur form, for the notations of formal language syntax. If you've studied comp sci, he has had a hand in your life.
Yeah, he really has.
And probably given you a headache or two.
Yeah, when I was looking into him, this guy's life is just straight up fascinating. While some view it as an apology for his efforts on Fortran, Backus's Turing Award lecture, which led to the distinction between value level languages and function level languages, was titled, "Can Programming Be Liberated from the von Neumann Style?" Now, while his intent with this was to promote and gain interest in the FP language, which was a function level language that he was developing, the paper had more effect in gaining interest for functional programming than in function level programming.
The von Neumann style of languages implements the von Neumann architecture, which applies to any computer that stores programs where getting instructions and data manipulation cannot occur at the same time. Most modern languages apply von Neumann architecture.
Yeah, pretty much all modern languages, except for a few that fall into the function level, apply von Neumann architecture. Um, Now, I just want to point out an unrelated point that John Backus, like me, also attended medical school and dropped out before getting into software and computer science.
So who knows what you'll inflict on us in the next 40 years.
So, first, we're going to talk about value level languages. Let's define what those are before we get into what Bacchus was talking about with the function level languages. Value level languages describe how to combine certain values with others until an ultimate result or final value is found.
All von Neumann style, and therefore most programming languages, are value level languages. Expressions on the right side of an assignment statement is how this basically works. These build values that can be stored or used to build other values.
Value level programming, the studies within it look at the values within value forming operations and kind of their algebraic properties. Like, what does it take to create these values and how are they applied to create other values? Within that, study of data types is a subset of studying these values, and it focuses on the axioms or algebraic laws around values. It's a whole nother rabbit trail to go down to look into this.
Talking about like all the type theory stuff, and
yeah,
that rabbit hole will keep you busy for a very long time. Even functional languages based on lambda calculus are value level languages. The functions return a value, which can be another function to be stored, passed into another function, etc., or used to form another value.
So that gives you an idea of what Bacchus was working against is basically everything up until that point was value level languages. Even stuff that he had created were value level languages. And he spent the latter part of his career and life, really, working on function level languages. Function level languages are variable free. So instead of variables, they apply programs to program forming operations or other programs.
Programs are built from other programs that are given on the outset by combining them by way of functions or program forming operations. So instead of creating successive sets of values, function level languages create successive sets of programs.
Yeah. So these function level programming languages allow for kind of a bottom up semantics by way of enforcing very strict functions. It doesn't really use inheritance. It doesn't lift like lower value level to higher function level images. So you don't have a value level image or a value level set that is then applied to a function. It is just pure functions and programs around those functions.
Yeah, this is kind of hard to describe unless you've seen it.
Yeah, it kind of is.
And if you've seen it, a lot of times it's kind of hard to understand where it would get used and to shift your headspace enough to envision that.
Yeah. Bacchus worked like most of his computer science career at IBM. And while FP was used, like that's the function level programming language he wrote, it was used in some Unix kernels and like mostly in academia. It inspired a few other languages. And then the other language he wrote at function level, FL, never got outside of IBM. Like it was part of a research project And then once that project was completed, it just disappeared. So while he spent the latter part of his career really pushing for this, it because functional programming became so popular, like function level programming was kind of overshadowed by functional programming.
Yeah, I mean, I still think he made a dent in the world. It's just not the dent that he meant to make.
Oh yeah, absolutely.
I mean, the difference between functional languages and function level languages is that function level languages have a hierarchy that goes from atoms to functions that take in one atom and return another, to higher order functions that will take in one or two functions and return another function. It's very hard to describe this in audio. I mean, it's interesting just to have it described on a whiteboard to you by somebody that has a PhD.
Yeah.
Because it takes them a hot minute too, and that's neither of us.
Yeah, I specifically picked this as the last thing we talked about because I thought it was interesting. Like, we hit the important stuff early on, like in the midsection of this episode was really what the episode's about. This is just some like really nerdy, neat stuff to think about within the world of programming paradigms. Guys, these are just a few of the myriad of programming paradigms available for study. While it's easy to think of a particular language as being one paradigm or the other, it's also very important to know the history of that language and how it can be used. A lot of modern programming languages allow for multiple paradigms, even if they were originally written with a particular one in mind. So, this episode has just sort of been an introduction to programming paradigms, a way to think about them, look at them, and, you know, do a deeper dive. For me writing this episode, it was absolutely a Wikipedia rabbit trail. Most of the stuff in here comes straight from Wikipedia, but it's also very fascinating. Guys, use the information here to better understand the languages and frameworks that you use on a daily basis and see how they relate to others that you interact with regularly. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I have a terrible pun, actually. And it actually, ties into the tricks of the trade. Remember that a paradigm is 10 times as good as your 2 cents. Paradigms. Sorry.
But took me a moment.
Yeah.
To get it, though.
But no, this is a real thing. When you are writing code in a language that is a particular paradigm, don't try to force the language into a paradigm where it isn't, because you'll basically blunt the ability of that language to do what it is supposed to do, and you'll confuse anybody who goes in there afterward. So, for instance, you'll see one of the common places you'll see this a lot of times is JavaScript, where somebody doesn't understand the whole prototypal system and what that means, and they try to fake objects in there in a way that is not JavaScript oriented, essentially.
Mm-hmm.
You'll also see this in newer languages where somebody does everything procedurally, along the same lines. And what that does is you're breaking the paradigm that language was written for and trying to make it, trying to hammer it into something that it isn't. And you will get in your own way very, very quickly if you do this. Now, it's fun to play and experiment and go, okay, I'm going to, do pure functions in C#, right? Like, you could do a fair bit of that. You just need to understand that there is a point there that you can't get past with the language, and to not try to force that until you have a construct that lets you.
I think you and I have both discussed this, especially when we were doing the episode on functional, about how, like, for example, when I write code, I write primarily functional because I like the declarative style. But it's primarily functional, and then I go to object oriented, and then I go to procedural.
I guess basically the thing is, if you're doing C# and you write code where you're in a code review and you have to explain what a monad is to an average web developer, like, that is a very bad place to be in terms of your team, right? And it's fine, whatever you want to do computer science wise, like you can make it work. But reality still asserts itself. Like your paradigm is essentially a communication protocol with the other programmers as well as with the machine. And you need to remember that. So,
yeah, that makes a lot of sense, because if the other programmers can't come in and add features, like let's just assume your code works perfectly fine. They can't come in and add new features, then you can never move on from that code.
Right. Or more than likely, it will be deleted, and so will your job.
Yeah.
So, that's pretty much all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.